Okay, class, this is for the STAT 2110. And the first week of class is going to be a little crazy with trying to figure out how everything goes and all. So what I thought I'd do is make this video. The notes are posted on Blackboard for you, so you can go through them. And at least on this one, I have some of them highlighted that are very important. So data are a collection of observations such as measurements, genders, or survey responses. A single data value is called a datum, but it's a term that we don't use very much. We are studying statistics. Statistics is the science of planning studies and experiments. In order to do this, you will obtain data. You will organize the data. You will summarize it. You will present it. You will analyze, interpret, draw conclusions based on them. Now that's a definition of statistics. We're going to talk in a little bit about what a statistic is. So make sure you keep them straight. This is the definition of statistics. A population is also very important. A population is the complete collection of all measurements of data that is being considered. We talk about the population of the United States. We talk about the population of the world. A census is a collection of data from every member of the population. And 2020 is a census year. So people received, a lot of times it was cards, asking them to go onto their computer and complete a census questionnaire. I know that there were plans, as they always are, for people to go and knock door to door, but the pandemic this year probably shortened some of that, and that was mainly for people who did not respond to the other one. A sample is a sub-collection of the members selected from the population. Your class is a sample of all the students who are taking statistics. It says, because the populations are often very large, a common objective of the use of statistics is to obtain data from a sample and then use that data to make conclusions about the population. We're going to talk a little bit about voluntary response sample. These are ones that are internet polls, mail-in polls, telephone calls, and one of the problems about them is they're not really reliable. And part of the reason is a lot of times it's only people who are interested who actually respond to them. So you have to watch when you get responses from a voluntary response system. Now I have to change the page, and I'm going to go to page 2 and hopefully not drop everything on the floor as I do this. And I will be changing as we go from page to page. And again, you do have all of these. Again, from the voluntary, you can only draw conclusions about the group of people who's chosen to participate. So they're often called flawed. Statistical significance is achieved in a study when we get results that are very unlikely to occur by chance. Example, if out of 100 babies, random, you get 98 girls, that is statistically significant because it is not likely that the results of a random chance. Normally, with babies, it's 50% boys, 50% girls. Practical significance is when some treatment or finding is effective, but common sense might suggest that the treatment of finding does not make enough of a distance to justify the use or to be practical. An example is the Atkins weight loss program. People do lose weight on it, but the question is, do you only lose 1 or 2 pounds? Do you lose 5? So there's a lot of things on that. Misleading conclusions. We must make statements that are clear, even to those that have no understanding. And one of the problems that ends up happening is that a lot of times we don't have any knowledge about what is going on. And so we have to watch for misleading conclusions. Reported results. Take measurements yourself. And I'm going to make a comment here. The coronavirus, of course, this year has been something that we've all heard about and is in our everyday life. And a lot of people have complained about the results. And what you have to remember is when you're doing a study, technically, if you're doing the study, you should do all your results. But when you look at just the United States with the 50 states and everything, no one person can go around and do it all. So we are relying a lot on people to give us the results. And since we do have 50 states and each state has a lot of different towns and everything, people are not always recording or doing things quite the same. So you have to watch a little bit when you listen to the results. Small samples, watch out for samples that are very, very small. If you only ask 5 people, that may not be enough. Watch for loaded questions. Watch the wording of questions. Also, possibly the order of them. Did you hear that report last night on TV? You may ask somebody. The one about the funding for the government. What did you think about that? Maybe that's not the way to ask the question. Non-response is when someone either refuses to answer or is unavailable. And you have to watch on the non-response, because what happens is sometimes people start surveys and then partway through they decide to drop out of them. And when they drop out of them, then they are no longer available to continue that. So you have to kind of watch when you do that. We are going to talk about percentages, and you have to know a little bit about them. To find a percentage, you multiply the number by the percent as a fraction. So if you want to find 8% of 900, remember percents sound very good, but mathematically you cannot use them. You would have to convert it either to a fraction or a decimal. Your book recommended a fraction, so 8 over 100 times 900 will give you 72. Talk about decimals to percent. Multiply the decimal by 100%. In other words, 0.83, if you multiply it by 100, would be 38%. Fractions to percent. Change the fraction to a decimal by multiplying by 100. So 3/8 would be 0.375, because that's the decimal equivalent, times 100 would be 37.5%. Percentages to decimals. Replace the percent sign by the division by 100, because percent means out of 100, and divide. So 73% would be 73 divided by 100 would be 0.73. That's just a little bit of review, and that was Chapter 1-1. Chapter 1-2, a parameter. Very important term. A parameter is a numerical measurement describing some characteristic of a population. So a parameter goes with a population. The two P's go together. A statistic is a numerical measurement describing some characteristic of a sample. So statistic goes with a sample. Quantitative. Quantitative means numerical, and that's data consisting of numbers representing counts or measurements. Age, time, money. Categorical or quantitative, or an attribute. Data consists of names or labels that are not numbers representing counts or measurements. Hint. Watch for numbers here, which are categorizing data. Numbers on a jersey don't measure anything. Example, Democrat, Republican, male, female. These will all be categorical. The next two terms that we're going to talk about that are very important, and some of these terms are going to come back through, are discrete data and continuous. Discrete data are results when data values are quantitative and the number is finite or countable. Example, the birth number. When people say, how old are you? You don't say, I'm 18 years and 3 months. You say, I'm 18 years old. If you count the number of books in a library, if you count the number of seats in a room, these are all discrete. Continuous is also numerical data, but it results from infinite many possible quantitative values where the collection is not countable. An example, your height or your weight. And you might say, well, I got on the scale this morning and I weighed 103 pounds. You really didn't. You weighed 103.1, 0.2, 0.3, 0.4. So it is something that, it looks like it's right, but you have to watch. How tall are you? Well, I'm 5'7". Well, are you really 5'7"? Are you 5 feet 7.2, 0.3? Are you really 5.6, 0.9, and you round it up? So watch on that. The next ones here are level of measurements. These are also very important. I did attach a video for you to watch, and they talk about when you go to determine a level that you run through from the smallest to the largest to see which works. I don't know that that's necessarily that important, but you need to understand the difference. Nominal is basically characterized by data that consists of names, nominal name, labels, categories. The data cannot be ranged in any ordering method, such as low to high. Examples of nominal are yes or no, possibly undecided. Social Security numbers, Republican or Democrat, color of your eyes, different things like that. Think about names. Ordinal level of measurement are data that can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. Example, a grade of A, B, C, D, or F. We understand what they mean. We can put them in order, but you can't subtract them. College rankings, when they give college rankings, this college ranked number 1 in the world. This was number 2. Well, yeah, you can subtract 1 from 2, but it doesn't really mean anything in terms of what you're doing. Interval and ratio seem to be the two that students have a hard time with. Interval level of measurement, if they can be arranged in order and difference between data values can be found and are meaningful, data at this level do not have a natural zero starting point at which none of the quantity are present. Example, body temperature. There's no such thing as a zero body temperature. Years. You're never 0 years old. Okay? So think of things like that. Ratio level is if the data can be arranged in order, so you see the similarity at interval. Differences can be found between the data, but these are meaningful also. But the main thing is there is a natural zero starting point. Example, the length of the car. You can go to the front of the car where it's 0 and you can measure the length. The length of a class. Heights. Distances. Hint, for ratio level, ask yourself the question, does twice make sense? For true zero, that means that none of the quantity is present. On the Fahrenheit scale, would 0 indicate no heat? The answer is no. So on temperature, on the Fahrenheit scale, is interval level of measurement. Continuing with chapter 1 and going to section 3. These again are things that you're going to have to know. Observational study is where you observe and measure specific characteristics, but you don't attempt to modify the subjects being studied. And an example would be where you survey a group and you see how many go online wirelessly. An experimental study is where you apply some treatment and then proceed to observe the effects on the subjects. Example, you give a group a placebo versus real medicine, and of course this is something that they do in medical trials. So observational is where you just stand back and you observe. Experiment is where you might give them something or do something specifically with them. It's an experiment. There are types of samples, and again, these you do need to be able to distinguish between. Most of what we will do will be a simple random sample where you have n subjects, that's however many subjects you have, are selected in such a way that every possible sample of the same size n has the same chance of being chosen. Systematic is where you select some starting point and then select every, they call it K, element in the population. In other words, I'm going to go out and I'm going to ask every 5th person that I see. I'm going to go out and I'm going to ask every 8th person that I see. So it's a systematic way of doing it. Convenience sampling is where you use results that are easy to get. So if I want to do a sample, maybe asking my class is easy because they're right there in front of me. Not always the best way though. Stratified and cluster, they kind of look the same, but there is a difference. A stratified is when you subdivide the population into at least 2 different subgroups, so that each subgroup has the same characteristics. Then you draw a sample from each group. So you divide them into men and women, and then you pick some of each. You go to a college or a university, you separate the freshmen, the sophomore, the juniors, the seniors, and then you take a few from each group. Cluster sampling is different. Here you divide the population into sectors or clusters. You then randomly select some of the clusters and choose all the members of them from the cluster, like selecting 2 streets or 2 cities. I'm going to go back to the stratified 2 to maybe talk about it. If we were to take and divide the students at a university into freshmen, sophomores, juniors, and seniors, and then take maybe the freshmen and the juniors, that would kind of be clustering, although it isn't something that we usually see done. And we're about to finish these. And this is the last page from chapter 1. And these are different types of observational studies. And there are 3 of them here. Cross-sectional is where you collect data at one point in time, not over a period of time. So you pick, I'm going to ask everyone teaching statistics at Robert Morris University on Tuesday to ask all their students the same question. Retrospective, if you look at the retrospect, you look to the reverse, to the back, is where data are collected from a past time period by going back in time through the examination of records, interviews, etc. For example, a lot of studies have been done about cigarette smoking and the long-term effects of it. So what they do is they go back and they may have had a group of people years ago who came in and said, I'm a smoker, and a group who said, I am not. And they might have done a study on those groups over a period of time, and now they're looking to see what conclusions they can draw. Prospective is for longitudinal or cohort study, and this is collected in the future from groups that share common factors. So this would be like going to a graduating class at a university asking them kind of, what do you want to do in 10 years from now? And then in the future, going to see if that's what they did. Confounding will come up on and off again throughout. It occurs in an experiment when the investigators are not able to distinguish among the effects of different factors. Example, using men and women as two separate groups. Sampling errors will come up again throughout the course. They are also called random sampling error. They occur when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population results. And these can result from some chance sample fluctuations. There's a little bit there about non-sampling error and non-random sampling error. You can read through those. They are not things that we talk about. They show up every now and then for things, but they are not as important. That concludes the terms from Chapter 1.